Okay, no questions, let's move on. Think about the bell work, we will get back to it later. And let's review yesterday's topic. We worked on finding the next term of a sequence. And yesterday the question also asked about the formula, but the formula we're going to work today. Yesterday was just about finding the next term of a given sequence. We worked on 3 examples. Letter A, we have the sequence 1 over 2, 2 over 3, 3 over 4, 4 over 5, and the next term of this sequence, of course, have to be, to make sense, right? For the sequence to make sense, it have to be 5 over 6. Nice, easy, right? Now, example B. We have an alternating sequence, -2, 4, -6, 8, -10. What is the next term? First, you think about the sign, look at the sign, and it's negative, positive, negative, positive, negative. The next one will be positive, right? Now look at the number. 2, 4, 6, 8, 10. The next one, of course, we are adding 2 on each step. The next one will be 12. So positive 12 is the right answer. What about the sequence from letter C? On example C, we have 1 over 2, 1 over 4, 1 over 8, 1 over 16. What will be the next number of this sequence? It's missing. Can you see? It's missing. I need your help. Tell me what's going to be the next number of that sequence. And yes, I think 1 over 32 makes a lot of sense. Right? Because the denominator, we're looking at the denominator. The numerator is easy. Numerator is 1, right? We repeat 1, 1, 1, 1, 1. And the denominator is going to multiply by 2 at each step. Multiply by 2, multiply by 2. So the last one, 16 times 2, 32. 1 over 32 is the right answer. Thank you, Brian. And thank you, Mia. Now, I think you are a little bit more confident to find the next term of a sequence. And it was not too hard, not too difficult. You have to think a little bit, and most of you can find the answer by yourselves. Today, we have something a little bit harder than yesterday, is to find the formula. Let me show what we have today. We have new examples. Now find the formula, okay? We know how to find the next term of the sequence, as long as we make sense. Now we need to find the formula of the nth term of the sequence. When we talk about the nth term, we're going to represent, the notation is this, A-N. And we need to find a formula or an expression that represent each one of the terms on a sequence. It's going to be a function of the order of the term on the sequence, which is n, right? A function of n. Let's analyze the first example. I think the first example is the harder one. Let's work on this, which is not too hard. Let's work on the last example first. 3 over 2, then 4 over 3. Then 5 over 4, then 6 over 5, then 7 over 6, and this goes on and on. Can you make sense of this sequence? Compare the numbers, numerators, denominators, with the order, with n. This is the first one, n equals 2, the second, n equals 1 for the first, n equals 2 for the second, n equals 3 for the third term, n equals 4 for the fourth term, n equals 5 for the fifth term. Good morning, Amber. So we compare numerators and denominators with the order n. And then we find the formula, a of n. Check numerator. is 3, 4, 5, 6, 7. So we can add, is n added to something, n plus something. And I think it's going to be n plus 2, because if we add 1 plus 2, 3, 2 plus 2, 4, 3 plus 2, 5, 4 plus 2, 6, 5 plus 2, 7. Makes sense? Yes? The numerator is n plus 2. And the denominator, I think, is going to be n plus 1. 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4, and this on. Makes sense. Yeah, that's the formula. Oops. That is our formula for this sequence. The numerator is n plus 2, the denominator is n plus 1. Okay? And tell me if you have any questions. Let me show the first example now. Because the first example I think is a bit hard. We're going to skip the second example because you're going to see on the quiz. On the quiz we have several examples like that. But look at the first one. Now the first one is a bit harder. I don't know how to make sense of this. Can you help me? 1 over 3, 1 over 9, 1 over 27, 1 over 81. And this goes on and on. Can you make sense comparing with n? This is the first, the second term, the third term, the fourth term. And let me tell you something. Analyze, think about the numerator separately, and the numerator will be 1, right? It's repeating. What about the denominator? We have 3, we have 9, 27, and 81. You need to have this maybe in your memory. 9 is 3 squared. 27 is 3 cubed. 81 is 3 to the 4th. So let me change this. 3 squared, this is 3, 1. 27 is the same thing, is equals to 3 cubed. And 81 is 3 to the 4th. Now I can see something. I can make sense. This, see, this is equals to n. The exponent is equals to n. So I can write an equals 1 over 3 exponent n. Okay, questions. I think we can work now on the quiz. We have the tools. It's a bit harder than yesterday, but I can help you with all the questions today. Any questions, all the questions. At the end of our class, I will give you the answers so you can check. Because I realized today is a bit harder than yesterday. Any questions? Any concerns? Any comments or feedback? Let's check it out. Well, which number completes the sequence? One thing we can notice is looking at the rows. Let's look at the rows. If you add all the numbers in a row, we're going to have 8 plus 1 plus 6, 15. 3 plus 5 plus 7, 15. And we don't know this, but we can also add all the numbers in the column. And 8 plus 3 plus 4, 15. 1 plus 5 plus 9, yes, 15. Great. And we can also add the numbers in the diagonal. Check this. 4 plus 5 plus 6, 15. Yeah, this kind of looks like a pattern to me. Another thing we can notice is that we have number 1, 3, 4, 5, 6, 7, 8, 9. We kind of have all the digits, right? All the digits. We just don't have 0 and 2. We just don't have 0 and 2. So if you try number 2, let's check if it makes sense. you're gonna add this column, you add this row, and add this diagonal, and the result will be 15, 15, and 15. So 2 is the right answer. 2 is the correct answer. Great. Thank you. Nice. See, it makes a lot of sense. And is the missing digit, right? This is the missing number. Today, you have to find the formula for the nth term of the sequence. The questions are very similar from yesterday. Some questions are the same. The sequences, some sequences are the same, but we have now today to find the formula. And we need to compare with n. So compare this sequence 2, 4, 6, 8 with the order n equals 1, 2, 3, 4. Okay? Yes, Mia, no problem. For letter A, to find A of n, we can notice that the term is going to be 2 times n, right? For n equals 1, the first term is 2. For n equals 2, the second term is 4. For n equals 3, the third term is 6. N equals 4, the fourth term is 8. So we can notice that we can calculate each term by multiplying n by 2. So this is the right answer for letter A. Now, work by yourselves. I will check real quick attendance and we can get back and work together. When we are working on alternating sequences, we will repeat this factor. Because it's an alternating sequence, I will start. The first thing you're going to do is to repeat the factor -1 exponent n multiplied by something, because this is what gives the alternating sign. Negative, positive, negative, positive, negative, positive. Okay? Now compare this, letter G, with something we have done before. Only the numbers. Compare only the numbers, not the signs. Look, letter B. See, the numbers look the same. So we can multiply this, that represents the sign, by that 3n. And that is letter G. -1 exponent n times 3 times n. Thank you, Lorena. Okay, compare letter A with letter C. And I think we can make sense. Look, 2, 3, 4, 5, 6, 7, 8, 9. Letter C is letter A, the sequence from letter A, plus 1, right? So letter C, the sequence from letter C, is the same sequence from letter A, plus 1. So we can write this as AN equals, the sequence from letter A is 2n, 2n plus 1, right? This is going to be letter C. And don't worry, I know today is hard, it's a bit hard. You got it almost right. Letter H. And let's check here, letter H. Alternating sequence, automatic. This is going to be automatic. Well, compare with with n. The first thing you're going to do is write down this factor, -1, exponent n, always if you have an alternating sequence. And now let's try to make sense of these numbers, because we have 2, and we can say 2 is 2 exponent 1. We can say 4 is 2 exponent 2, 8 is 2 exponent 3, 16 is 2 exponent 4, So the next number is 2 exponents n. See? Each factor, if you look only at the number, is going to be 2 exponent n. To add the sign is -1 exponent n times 2 exponent n. This is the complete answer. Thank you, Brian. And now we have the whole thing. I think we have all the answers.